Hello, good day. Welcome everybody to this webinar from Mender.io in association with its partner iWave and Unitronic. The webinar is on security, over-the-air updates and embedded design challenges in connected mobility in the automotive sector. I'm joined here today by some eminent guest speakers. First of all, our very special guest speaker is Werner Nehaus from Unitronic. He's a business unit manager there, and he's a very experienced executive in the world of connected mobility. We're also joined by our own head of technical product marketing at Mender.io, Farshad Tabakoli, who will be talking about the importance of robust and secure OTA software updates for use cases in connected mobility and telematics. So today's lineup, we're going to look at the emerging use cases in connected mobility. What are the considerations for OTA software updates? And then iWave and Unitronic are going to examine the embedded design challenges and considerations in telematics hardware, and then explore some strategies and tactics that can enable a product designer to integrate security into the product design cycle. The flow of the webinar, we'll have the presentations first, but as attendees, you'll be able to drop your questions into the Q&A box in the webinar. We'll pick up those questions and we'll put the questions to the panelists at the end of the session. I just understand that some of our guests are having some problems with the audio. I believe Anish Monakan has a problem with the audio. If you can try dropping off Anish and coming back in, that might help. But with that, I'm going to hand over to our special guest, Werner, who's going to begin the presentation.
Right, thanks a lot. So not only a Tesla car, but even a mid-class conventional car today is featuring lots of electronic units, with many additional aftermarket solutions being available on top. No matter if we think in terms of safety, security, or comfort, the availability of the necessary information is key to a successful and reliable implementation of connected mobility. Connected mobility starts on the vehicle itself. Components and subsystems are combined to driver assistance and infotainment systems through onboard networks. The vehicles are connected to the mobile internet and links the onboard net with the internet. New services emerge this way and deliver additional benefits. Intelligent HMI solutions support easy organization and prioritization of information. Next slide. Maintenance scheduling in general becomes a kind of automated process. And in the case there being the threat identified for the car to break down, service stations can be recommended by the car, selected and chosen by the driver. Continuity of mobility can be guaranteed through appropriate services. No matter if we think in terms of a car sharing or logistics services, through telematics, all the necessary data can be made available to set up and organize best the fleet management system, reducing downtimes, unnecessary movements, tracking of the vehicles, and observing the conditions of the goods, for instance, food and vegetables, medicine, etc. Cars start identifying the driver and recognizing the preferences like seat positions, positions of mirrors, climate, music, etc. Connecting vehicles with the infrastructure and other vehicles, even without being connected to the internet, offers the possibility to increase the limit of redundancies and security, therefore, despite the ability to organize a better guidance of traffic and a much smoother and continuous flow of the traffic among many other potential outcomes. Next slide. Design cycles of cars are long usually. with extensive testing following and production after that. We do experience in our professional and consumer lives that software is never ready, and accept update services on all our electronics devices, whether it's smartphones, tablets, even consumer goods like TVs. I think everybody agrees it not being comfortable for every software update to consult a service station with your car. Downtimes must be avoided as much as possible, therefore. Improving or extending functionality might be considered or even necessary and can be enabled without disturbances. The sensors already being available on the car produce a significant amount of data already. These data offer the great opportunity to continuously deliver the chance, adding new use cases derived from applied artificial intelligence on the implemented algorithms.
Great. Ed, I just wanted to check in the audio here. Can everyone hear me? Or
yes.
Werner, can you check?
Yes.
Okay.
Yes.
No echoing? No echoing? Let me know.
No.
So essentially continuing with that, in general, we know automotive has a long life cycle, typically 5 to 10 years or even longer. When you think about the embedded environment in this situation, in automotive, they're obviously expensive to reach physically. Fleet management becomes even more critical for in-vehicle systems from production to end of life that may require different types of software updates at varying stages of the vehicle life cycle. During the development cycle, software updates may need to be changed across a fleet of pre-production vehicles. They may be in different parts of the world and may need different types of updates. A lot of talk around the experience per mile with some of the leading companies in this space becoming experience per mile, or EPM, as the new metric versus your RPM or MPG and really trying to improve the end-to-end experience in the transportation ecosystem, all the way from the supplier to manufacturer to consumer. Software updates play a critical role in improving this new metric in various phases of vehicle life cycle. So it's that sort of thinking behind that. The connected vehicle operates under a certain network environment that can drive new requirements. You have unreliable connectivity and loss of power, data transfer cost. If you want to connect to the cloud and send terabytes of data, bandwidth speed is a constraint, and obviously security as well. So under such environment, in addition to having robust and secure OTA updates, reducing risks and increasing efficiency also becomes important. And other situations where uptime is also important, and you need capabilities to do both system and application updates. We'll cover a bit of that in slides 3-4, in the next 3-4 slides. And then, given this environment that the vehicle is in operation, drives a lot of the requirements for a fully optimized end-to-end software update solution that is focused on minimizing risk, increasing efficiency, and enhancing security and uptime. Next slide, please. I'm not going to cover the details of this slides, but implementing a secure software update process requires preventive strategies against a number of potential attack vectors. This table shows this is a small portion of just a cut of what potential security threats related to software update systems, along with the weaknesses that make them possible. Highly encourage our viewers to download the latest white paper on security that covers this topic in more depth and talks about Mender's defensive strategies against these potential attack vectors. Next slide, please. Yes, robustness and security. So essentially, the prime directive with Mender is to maintain robustness and security. By security, we mean using industry best practices, TLS encrypted communication, which so it ensures the privacy of the communication channel and keeps the data safe from prying eyes. Public-private key image signing ensures that your clients will not install arbitrary code, piece of software. The device authentication workflow also allows you to carefully control which devices can connect to your fleet management system, and allows your system to verify that the devices are authenticated. Essentially in the vehicle system, the modules you have. Robustness means primarily that we will never leave a client device in a brick state in the field. Redundant root file systems are used to ensure that there are known good fallbacks when bad updates are installed. This also ensures that the updates are atomic, meaning that no component in the system will ever see partially installed software update. And lastly, like integrity checks and appropriate device grouping also allows you to ensure that the right images are installed on only the required devices or modules in the vehicle system, helping to maintain the overall health of the fleet. Also, Mender is intended as a background mechanism running on the device, meaning that your application stack continues to function while updates are downloaded and installed. So only the reboot to switch to the new partition or the new software will have any impact on the usage. Next slide, please. So there are generally two different methods for updating a connected device, whether it's a gateway edge computing device or an ECU in an automotive application. The first part is what we call the system updates, and in a system update, the whole disk partition is updated, even if the update only entails a minor change in a file. The update will include all the software and firmware on the device. The second method, which is more on the application in a system, the application only updates certain parts of the software on the disk. If there is only a minor change in a file, the update will only include a new version on this file. So which type of update method to opt for depends really on the needs. In automotive, you could perhaps be doing more frequent application updates to release new features running higher up in the stack, such as like your UI application and infotainment system. Or a more common case would be map updates, and perhaps more of that system full disk image updates in an ECU related applications such as an engine control module. And these frequency of updates could vary throughout the product lifecycle or vehicle lifecycle. There are pros and cons for each method. For example, in the case of the system update, you get the robustness and atomic updates, but then you could be installing a huge file that could take 30 to 60 minutes. So your downtime would be much longer. On the other hand, you could be doing more frequent, faster, and smaller package updates, but then the device could break in an event of power or network loss. So there are trade-offs to consider here and to be aware. But Mender fully delivers on both use cases. Next slide, please. Here we have a couple of use cases that are paramount in a vehicle or automotive use case. What we call at Mender phased rollout or campaign management. You can greatly reduce your risk here. You can divide a software update deployment into a time delayed phases with customizable share in a fleet of cars being updated in each phase. For instance, for example, you could be deploying to 5% of this group of cars in this region, wait for 24 hours, then 15% for perhaps wait another 24 hours, and then so forth till all the remaining cars in the fleets are updated. It gives you the ability to define essentially a deployment plan based on your needs and risk levels. You can also monitor this progress through our UI. With Delta updates, this is a major use case as all vehicles will be on the cellular networks. So Delta updates, you can save obviously data transfer costs and get a much faster download speeds over cellular network. With automatic Delta updates, the server will automatically manage the correct Delta update file to the correct vehicle or device in heterogeneous fleets, saving a lot of staff time managing deployments across large and diverse fleet of vehicles, if that's the case. And yeah, and with that, I'll just hand it over to Tafiq from iWave. Thank you.
Thanks, Farshad. Tafiq, can you hear us? I know you had some difficulties getting into the webinar, but are you here now?
Yes, Stephen, can you hear me?
Yes.
Great. Thank you, Tafiq. Over to you.
Yeah. Thanks, Farshad, for this good intro on in terms of robust and secure OTA updates and the progress. So now I will complement.
Hello, Tafiq. Can you hear us?
Yes, Stephen. Can you hear it? Can you hear me?
I think Tafiq is still having some.
I can hear him. I can
hear him too, Stephen. Great. I can hear Tafiq.
Okay, go ahead, Tafiq. Thank you.
Sure. So I would like to highlight a few key design challenges on the embedded side, which will be complementing the OTA software. So
I think we lost him now.
Yes. Can I ask Werner to step in, please, on behalf of iWave?
Yes.
Present the slide as their value-added distributor. Thank you.
So Tafiq just came to the evolving technologies. This is in terms of communication, where 3G is going to disappear, and now we have 4G and 5G is coming, and we are supporting all these technologies, including Cat1, Cat-M, Cat4, no matter what, the DSRC, C vertical to X, so to other vehicles or to the environment. Bluetooth, coming from Bluetooth low energy at the 4.2 standard. Now it's moving towards Bluetooth low energy 5.0 standard, which is supported on the devices as well. There are region-specific connectivity challenges to be overcome as well. So there's different bands that are not always available in every specific region. Compliances with the regulations in the various regions is another challenge to overcome, and the bandwidth availability. I said already there's a Cat-M available, but not everywhere available. Then we have others like Cat1 and Cat4 connectivity with the bandwidth, which is different in various regions. Range of interfaces in the car supported is we've got the CAN FD interface, high-speed CAN as well as low-speed CAN on the different models of the car with the different car manufacturers as well. We want to have one device which is going on to all these devices. Coming up is the automotive Ethernet, which is in the upper class cars available now as well, which is also supported Wi-Fi standard, where we are now at the Wi-Fi 6, is going to be supported as well as the UWB interface, which is another challenge as well. What is coming up as well called artificial intelligence. So the intelligence, the processing power, the intelligence is moving to the edge. So the processing power is increasing, but with that also the power consumption as well. So proper and reliable power optimization is another key challenge to overcome in the design, and is required to be managed. Next slide. So the device from iWave is scalable. So with all the functionality, the different functionality, it has been tried to become as flexible as possible. So you can scale towards the functionality of your various cars, your various needs and requests for your devices. This is done through population options, where you do not need to have all the various functions being implemented at the first stage. So this way you can scale up your device towards the requirements of your car, whether you come from a low-end car up to the very high-end family, where, for instance, the Ethernet is being part of the communication channels. Next slide. Yes, the importance of the security is has already been highlighted before. So when the device is on the market and you detect a problem with your security, you need to be able to, in the field to improve the security or to make the device secure at all. Calling back all the devices, as said earlier as well, is very, very difficult, and not only difficult, also expensive, and of course not very comfortable for the user as well, for the car user to go to the service garage and then get everything fixed. So the TCU and ECU, the brain of the vehicle, they are providing a gateway and provides a rich gateway for hacker as well. So protecting the security of the car and device as such is another key item which needs to be managed very, very well. And all kinds of secure elements are being and must be implemented and integrated during the design of the device, which is another challenge to be overcome as well during the design cycle. Next. So strategies and tactics for the security. There is a root of trust, so silicon to cloud, which means that the security is part of the silicon and talking to the cloud. So there is an identification process. The secure boot system being implemented, as well as secure provisioning being taken care of in the very early stage of the device. Security integrated on the processor, which is a hardware security implementation, is being supported as well, and is very, very key to avoid hacking of the device as much as possible. Key management. Exponential in nature, but key management, the secure key to be managed is also a very, very important and very challenging exercise, which has been managed by iWave as well. Other than that, there is then the encryption and decryption process, which is needed to be a secure process as well, and is also an offering which is implemented in the strategy, secure strategy and capabilities of the iWave device on real-time performance, of course.
Werner, thank you very much for picking up on behalf of Tawfiq and the iWave team. That was really excellent. Thank you for that. So that concludes the presentation. We do have some questions that have come in from the attending audience. We have a question, Farshad, for you from Jürgen Fitchen. Jürgen asks about the AB partition scheme that you mentioned for rollbacks. Can you talk a little bit more about how that works? In particular, is the user configuration persistent in the AB scheme?
Yeah, so essentially the AB scheme, you have two partitions and you have rollbacks. Essentially the current software that runs on the device is on a certain partition. That partition needs to be integrated when you do the integration with Mender. So the integration, the recipe that you integrate Mender with your device partitions the memory, the disk, and then one partition runs the current software, the other partition runs the updated software, and then during this process, this is how the fail-safe happens. If by any chance the power is lost or connectivity is lost, you can always maintain your current software without damaging the device, and then the device rolls to the new software when the device is rebooted.
Thank you, Farshad. I think I have a question for Werner too. It's about, you mentioned the emergence of edge computing and more, obviously, local computing being done on the edge. Can you talk about that in the context of the automotive use case? What's happening there?
Yes. So what we see is that a lot of intelligence is being pushed to the edge. So you have a distributed system, so that basically the algorithms are run where the data are being generated through a sensor or on other ways. So the processing starts not with the data being transferred all the way from the data generator into the cloud, and then it's done on a server in the cloud, but the processing itself and the algorithms are already applied where the data are being generated. This, of course, allows for less data transfer, as well as the fast processing, and even the information being available where they are being generated and may be required without distributing too much.
Thank you, Werner, for that nice answer. I think we have one final question on IoT cybersecurity as it relates to the connected mobility use cases. We know with Mender and iWave that there is end-to-end encryption on both the software updating process, but also the hardware. What are the emergent threats? Either Farshad or Werner, do you have some examples of the emerging cybersecurity threats that we would see in the case of connected mobility? Do you have any examples you can share with the audience?
Tawfiq is not being heard.
Farshad, do you have any example you could share?
Tawfiq, you want to take that? Or are you online? Okay. On one of these slides, I listed out a bunch of different, and that's just a portion of sort of in the software update process where you can have different vectors, different loopholes where you can essentially do either install malicious software, unverified software, physical attacks, device server communication type attacks that could happen during the update process. But not specific top of my head in terms of specific example.
Okay, thank you, Farshad, for outlining some of the risks there. I think that's it. We don't have any more questions. I'd like to thank Werner for his splendid presentation and for also being able to step up and address the presentation on behalf of Tawfiq because of some of the technical issues, unfortunately, that Tawfiq faced. And thanks to Farshad for outlining the importance of robust and secure OTA software updates. And I'd like to thank our audience for joining us today too. A recording of the webinar will be sent around to everybody afterwards so they can review it in their own time. So with that, I'd like to wish you a good afternoon and thank you again for joining our webinar today.